Welcome back to Mishler Math. Today we're going to talk about exponents. Okay. Exponent properties. If A, and let's make it B too. No, let's make it A for now. If A is a real number and N is a natural number. So A is a real number, N is a natural number. Remember, natural numbers are the counting numbers 1, 2, 3, 4, 5, 6, 7, etc. So first we have A to the N equals A times A times A times A N times. There's no big mystery about this. You've been doing this for a long time, like for example 4 to the 5th power equals 4 times 4 times 4 times 4 times 4. There are 5 factors 4. Okay? 4 to the 5th power does not equal 20. You do not multiply 4 times 5. You multiply 4 times 4 times 4 times 4 times 4. That's what that's all about. The next one, if A does not equal 0, in other words, this won't work with a base of 0, then A to the 0 power equals 1. Okay? This means 27 to the 0 power equals 1. 4,975 to the 0 power equals 1. Negative 296 to the 0 power equals 1. And of course, x to the 0 power equals 1. Then we have A to the minus n. Okay, that equals 1 over A to the n. So that means that 6 to the negative 2 power equals 1 over 6 to the 2nd power equals 1 over 36. X to the negative 4 power equals 1 over x to the 4th. Get it? When you have a negative power, you're talking about a reciprocal. And that's it for that bunch. And let's look at the next bunch. Hey, properties of exponents. A, back up here, we're going to, alright, A and B do not equal 0, and A and B are real. Okay? M and N are integers. Now, you have to write this stuff. You can kind of put this aside, but you have to write this because these are the conditions for what we're talking about. So the product of powers goes like this. A to the M times A to the N equals A to the M plus N. What that means is A to the 5th power times, and I don't like to use A, that's what we started with here, x to the 5th power times x to the 3rd power. Think about that. X to the 5th power is x times x times x times x times x. And x to the 3rd power is x times x times x. How many factors do we have? 1, 2, 3, 4, 5, 6, 7, 8. And so this equals x to the 8th power, which equals x to the 5th, or x to the 5 plus 3. So if you're multiplying and they have the same base, you just add the exponents. That's all that means. Very simple. Look at the next one. Quotient. A to the m over A to the n equals A to the m minus n. If you are dividing, okay, let's say you have x to the 4th over x squared. Well, x to the 4th is x times x times x times x. X squared is x times x. Look, cancel x for x and x for x. Okay? What do you get? X to the squared, which equals x to the 4 minus 2. Okay? So you subtract. That's all you do. You subtract exponents. when you're dividing. Remember, you have to have the same base. Okay, very, very important. Power of powers, a to the m raised to the n power. This is often mixed up with this one, but this one, you a to the m times n. You multiply this. Okay, let's look at an example. Let's say you have x to the third raised to the second power. Well, that's x times x times x raised to the second power, which is x times x times x times x times x times x, right? And how many factors do you have? You have 6, which is 2 times 3. Not 5. You don't add them. You multiply them. Think about this. Now, the reason I spell this out for you like this, and I show you these things here, the reason I'm doing this is because if you're taking a test and you forget one of these powers, you can actually very quickly do this in your head or do it on a piece of paper and say, oh, that's right. That's what I'm supposed to do. Time and again, I have done that, and it works great. Another one, we're talking about the power of products. A times B raised to the n power equals a to the n times b to the n. For example, x, y to the second power. Okay, that's x times y times x times y, isn't it? How many x's do you have? 2. How many y's do you have? 2. X squared, y squared, like we said. Okay? One more here. And this one is going to be product of quotients. A over b to the n power equals a to the n over b to the n. Okay? And so how does that work? Suppose you have, let's say 9/3. I'm going to make something real simple, to the 4th power. Okay? That equals 9 over 3 times 9 over 3 times 9 over 3 times 9 over 3. And what does that equal? 9 to the 4th over 9 to the 3rd. Or excuse me, 3 to the 4th. It must be getting late here, huh? So 9 to the 4th over 3 to the 4th. Okay, so think about this now. 9/3 is 3, right? 3 to the 4th equals 3 times 3 times 3 times 3, which equals 81. Take 9 to the 4th, divide by 3 to the 4th, and I'm pretty sure you'll find out that that also is 81. So it works real well. You say, Mr. Mishler, what do we do with all this wonderful information? Oh, I'm so glad you asked. What do you have? Suppose you have 2z times 3x squared times 5x to the negative 3. And you say, simplify that. What does that all add up to? Well, first of all, I can multiply 2 times 3 times 5 because I don't have any exponents on the outside of these parentheses. So I can say 2 times 3 is 6 times 5 is 30. And then I have a z here, so I put the z in here. And how many more z's? I have x squared times x to the negative 3. Well, remember that this one is actually 1 over x third. Remember that? So I have 30 times z times x squared times 1 over x to the third, but that's going to be 30 times z squared, or excuse me, times z times x squared over x to the third. And now, what's 2 minus 3? X, right? And this is x times x, this is x times x times x. Alright, so make it real simple and sweet. I've got 30z over x. Notice I don't have any negative exponents. I could have said 2 minus a negative 3, okay? Or 2 minus 3, which is negative 1, I'm sorry. And that would be 30z x to the negative 1 power. But I don't want a negative exponent. That's not simplified. When I have a negative exponent, then I'm in the wrong place. So I still have more work to do. So 30z over x. Let's try another one here. And move over here. Shall we? Yes, we shall. This is a little bit more complicated. Say negative 3b squared c to the 5th over c squared b to the 7th to the 3rd power. I'm going to do everything inside here first before I raise it to the 3rd power, because I can see I've got a couple things I can cancel. 2 minus 7 is negative 5, so in other words, I can get rid of this and I can make that a 5 there, okay, on the bottom. Say, well, why? I thought you said negative 5. Yeah, 1 over b to the 5th is the same as b to the negative 5. So then 5 minus 2, so get rid of that and make that to the 3rd power. 5 minus 2 is 3. So that helps a little bit. So now I've got negative 3 c to the 3rd power over b to the 5th. Raise that to the to the 3rd power. So negative 3 to the 3rd power, or let's make it this, negative 3 c to the 3rd power over b to the 5th to the 3rd power. That equals negative 3 to the 3rd power is negative 3 times negative 3 times negative 3. Now when you raise a negative to an odd power, you're going to get a negative. 3 times 3 times 3 is 27. C to the 3rd power, 3 times 3 is 9. C to the 9th. B to the 5 times 3, B to the 15th. Okay? And by the way, we're going to be doing an awful lot of practice, because it takes a lot of practicing with these things in order to get used to these things and get them right. Finally, we got one more couple of little things here that we got, little doodads that are important, and that is a to the 1 over n power. That is the nth root of a. In other words, if I have x to the 1/2 power, that's the square root of x. If I have x to the 1/5 power, that is the 5th root of x. And if you're not familiar with what are we talking about, we talk about the 5th root or the square root, well, we have to work on that a little bit. The other one is a to the m over n. That equals a to the 1 over n to the m power. And remember, this is equal to this is equal to what we see above, which is the nth root of a. And we raise that to the m power, which is the same as the nth root of a to the m. And this looks a little confusing at first, I know, but let's try this in real life, shall we? Let's try 64 to the 1/3. Well, that equals the cube root of 64. In other words, when we're looking for the cube root, we want to know what number x times x times x to the 3rd power equals 64. So what does x equal? That's supposed to be a question mark. Alright, well, the answer is 4. Okay, and the reason for that is 4 times 4 times 4 equals 64. So the cube root of 64 equals 4. Okay, or 64 to the 1/3 power equals the cube root of 64 equals 4. And then let's try one more of these doodads, and that is 36. Let's get a different color here. No, this one. Okay, 36 to the 3/2 power. This is where I'm going to use this one down here. So I got 36. Okay, the 36 to the 1/2 power to the 3rd power. Okay, remember 1/2 times 3 is 3/2. So I got that 36 to the 1/2 power is actually the square root of 36 to the 3rd power. What's the square root of 36? 6 to the third power. 6 times 6 times 6 equals 36 times 6 equals 246. And hopefully that, oops, 216. My bad. This is why I push buttons on occasion, okay? And speaking of pushing buttons, let's try that right now, shall we? 36, and this is where you really need to use parentheses. 3 over 2 is, ba-ding, 216, like I said. Okay? Thank you. Bye.